So next topic is application of maximum and minima. This is our last topic of in this unit. Our the definition is increasing and decreasing test. First, increasing test is if f dash of x greater than 0 on the interval, then f is increasing on that interval. Next, f dash of x less than 0 on the interval, then f is decreasing on that interval. Next definition is first derivative set. Test suppose that c is a critical number of a continuous function f. If f dash changes from positive or negative at c, then f has a local maxima at c. If f dash changes from positive negative to positive, so if f dash changes from negative to positive at c, then f has a local minimum at c. If f dash does not change sign at c, then f has no local maximum and minima at c. Next, concavity test. If f double dash of x greater than 0 for all x in I, then the graph of f is concave upward on I. Next, f double dash of x less than 0, the graph f is concave downward on I. Inflection points. Next inflection point is a point P on a curve y equal to f of x is called the inflection point. If f is continuous, there is and the curve changes from concave upward to concave downward or from concave downward to concave upward. Second derivative test. Suppose f double dash of s double dash is continuous near c. If f dash of c equal to 0 and f double dash of c greater than 0, then f has a local minima at c. If f dash of c equal to 0 and f double dash of c less than 0, then f has a local maxima at c. So our example sum is for the function f of x equal to 2 plus 2x squared minus x power 4, find the interval of increase or decrease, local maximum and local minima values, concavity and inflection points. Our first question is find critical values. So given function f of x equal to 2 plus 2x squared equal to x power 4, first derivative f dash of x equal to 4x minus 4x cube. Next step is f dash of x equal to 0. For 4x minus 4x cube, we take common value is 4x into 1 minus x squared equal to 0. So x equal to 0. Next, x squared equal to 1. X equal to plus or minus 1. Here our critical points is 0 plus or minus 1. Next we find intervals. We divided this intervals to 4 types: minus infinity to minus 1, next minus 1 to 0, 0 to 1, next 1 to infinity. So next we find sine of f dash. We applying minus infinity to minus 1. Between value we take one value minus 2. We applying here. Our solution is negative. So behavior of f is decreasing. Next interval is minus 1 to 0. Here we take one value x equal to 0.5 minus 0.5. Here we get positive values. So increasing. Next interval is 0 to 1. Here we take 0 to 1 between one value is x equal to 0.5. Applying f dash of x, we get positive value. So behavior of f is increasing. Next 1 to infinity, we take one number x equal to 2. Applying f dash of x, we get negative value. Behavior of f is decreasing. Next, first derivative test tells that there is a local minima at x equal to minus 1. We applying x equal to minus 1 in f of x, we get 3. Next, there is a local maxima at x equal to 1. F of 1 equal to, we applying x equal to 1 in f of x, we get 3. So these are all our local minimum and maximum value. Next, we find f double dash of x equal to 4 minus 12x squared. Next step is f double dash of x equal to 0. We get x values plus or minus 1 by root 2. We divided interval is minus infinity to minus 1 by root 2. Next minus 1 by root 2 to 1 by root 3. Next minus 1 by root 3 to infinity. Next sine of f double dash of x minus infinity to minus 1 by root 3. Between the values we take one value x equal to minus 1. Applying f double dash of x function we get positive. So behavior of f is concave up. Positive mean concave up, negative mean concave down. Next we find inflection points is we applying x value equal to plus or minus 1 by root 2, we get 23 by 9. So this is our inflection points. Thank you.